All right. We are going through physical chemistry. So for those who missed the the last lecture we had, so it's now an opportunity that you at least you should grasp one or two things. All right. Okay. So in it, we look at complete derivatives, partial derivatives, temperature conversions, chemical thermodynamics, everything like that. So we'll talk through all those things. Okay. So that is it. So suppose now, since we are saying we are doing 270 and that's physical chemistry. So in this one, we'll talk about things like chemical thermodynamics. All right. Okay. So what is this chemical thermodynamic we're talking about? So we know thermo simply means heat, light, and the dynamic something that changes. So we'll say chemical thermodynamics just the study of heat or how the heat changes. All right. Then from there, we'll talk about, so since we are talking about heat to be changing, right? Let's say in a reaction. So we'll say, let's say this is our system now, all right? Then around it, we'll find what we call now the universe. Okay. So the universe is just outside the what? The system. And the system is what where we are interested in. All right. So then the surrounding will be this place. All right. So we are studying heat, guys. All right. So that's what will be happening. Let's say, suppose this is our, let's say, our beaker, everything like that. So outside our beaker, that's what we call the universe. All right. Then the universe now inside contains what we call our system. All right. Then from there, then we say this is our system. All right. Um. Then we need to know that there it's not only one type of system. We'll find a lot of system. All right. So there will be a lot of system that we'll find, and it's important that you actually get to know the type of system. So the first type of system we can talk about is what we call open system. So when a system is open, we say the system in this case will be, let's say, our beaker where the reaction is taking place. All right. So suppose this is our beaker now. Okay. So we'll find that this beaker is open there, and there is, let's say, a hot water or just a chemical reaction inside there. So what will happen is that we'll see it evaporating, right? So in that case, the liquid inside is reducing by mass or just by the signs it has. So we're going to say now both the matter itself and also the energy, since we're interested in the heat will be lost, all right, lost heat, and also the energy, the size itself, what will reduce. All right. So that's just the matter itself will reduce and the energy will reduce. All right. So they will be losing like spontaneously. Okay. And also in energy. All right. So both will lose both in the open system. Then when you talk of now closed system, so we'll have also what we call now closed the system. All right. So in closed, the beaker is just, let's say, the beaker is closed like that. All right. So we can see that since the beaker is closed, but outside there, because of the surrounding that we have, okay, some heat will be lost. All right. Because of what? The vessels that we are using. So, but the matter won't be what reducing in that it can't evaporate in that case. So say heat will be lost. That's energy. All right. Heat is just some form of energy, guys. Then the matter won't reduce. So we're saying when it crosses, then just know that is what um, only heat can be exchanged by means of our vessels that we are using, which is weak for that case. So we have also the last type of system as the isolated system. So in this system, let's say the beaker is here, right? In this case, we can't even bring a beaker or bring or something that doesn't allow matter, um, even just the heat itself to be, and that's, let's say, a flask. Okay, a flask is made up of some materials that won't allow heat to be lost. All right, and also since it has a lid, something like that, it will close, you close it on top there, and also matter won't be lost. All right, and also the heat won't be lost. So in isolated, you find that there are two of them. All right, both won't be lost. Okay, so we did these things in class, and if you missed, those are the things we did. So expect such thing that our lecturer taught, and do make sure that you understand everything which was learned. Right. So suppose now we'll go to what we call now unit conversions. All right. So in this one, we talked about things like we need to know that volume itself, volume will be found by saying breadth, all right, height, and what length, like that. So by this, breadth is measured in what? In meters, all right. Length, height is also measured in meters, all right. Length is also measured in meters. This will give us what? M cubed, like that. Okay. So volume will be measured in cubed liters. All right. So um we need to know that 1 meter, all right, just 1 meter, all right, is equal to actually 10 mils. All right. Then what you are going to do, no, is actually, yeah, so what you are going to do, let's square this so that we get to have what? 1 meter cubed, like that. So if you have 1 meter cubed, like that, this is equal to what? 1000 what? Mils. All right. And we need to know that 1000 mils, all right, is equal to 1 liter. All right. This, the same 1 liter will be equal to 1 decimeter cubed. So you need to know all these unit conversions, and sometimes you can be asked to say, you need to know again to say, when I give you, let's say, um, 1 liter, all right, what will be this in terms of um, um, meter cubed? So 1 liter, it will be actually 0.00, all right, 1. Okay, so it will be 0.001 meter cubed, like that. Okay, so master this. So in short, wherever there's 1 liter, you can also put um just 10 to the power what? -3 meter cubed, like that. So we'll use this at some point. So make sure that you understand this. All right. So that's about volume conversions, everything like that. So we can now go into temperature conversion, and also we'll look at some questions. All right. So now, in terms of temperature, temperature is just something actually. Since we'll be studying heat, temperature will be one of our interests. So we need to know that temperature itself will be using temperature in kelvins, right? And we need to know that a Kelvin will be gotten by, let's say we have a degrees Celsius, a certain temperature in degrees, then we add what? 273. So sometimes you can say 273.15, like that, or just 273, but they normally give this a specify. But just know that whenever you have um, a certain temperature in degrees, then you replace there and add plus 273. All right. So the 0 degrees is equal to what? 273 Kelvin. So this is Kelvin, by the way. All right. So that is it. Then we can um, um, we can do this. Remember, all these I'm mentioning here, they are going as a result of we said we are studying thermodynamics, and the thermodynamics we say it's just a change of heat. All right. So change in heat will be caused by these factors. One, suppose we have, let's say, a balloon here, right? When you reduce the volume of this balloon, you actually what? The wake or just the heat itself will be created inside there. The particles will be colliding frequent. So that's what we are talking about. That's why we are involving volume. When you reduce volume, you cause a problem. And also when you apply pressure there, you cause what problem there. All right. So now let me talk about pressure. So we need to know that pressure is a force per unit area. So when you say pressure is a force per unit area, all right, so we know that force is measured in Newton, and pressure and area is measured in what? Meters squared. All right. So by this we can say Newton per meter what? Squared. All right. So that will be what? Our units for pressure. We know this. But again, the one thing that we need to know is that when we have 1 Newton per meter like that, or meter negative with that, which is just per, then this will be equal to what? To 1 Pascal as well. All right. So Pascal is one way of measuring pressure. You need to know that. Then there is what we call atmospheric pressure, which is actually related as abbreviated as what? AATM or ATM like that. All right. So this will say 1 ATM, you know, you can see here. This will be equal to actually 10 13.25 Pascal. All right. So that would be 1 ATM is equal to what? 10 13.25 Pascal. Then from there, the same 1 ATM, it can be what? So we are just interested. We won't talk about the muse per mercury, something like that. We just talk our area of interest. So we need to know that, let's say I don't have a point here, but I can divide um 1, 2, 3 like that. So I can say the same thing here. I can just move the point here. I can say 10 1.325 like that. Then I light it times what? 10 to the power 3 pascals. Have you seen the point? So if I multiply this 10 again to the power 3, it will still what? Still it will bring back to the original equation. All right. So now um what I'm going to do is I'll say, since I have this, wherever there is 10 to the power 3, that's a kilo, right? So I'll say 1, 3, 2, 5. Then wherever there is this, I'll put a kilo. So that will be a kilopascal. So when you are told to say express in a kilopascal, just divide by what? Divide by 1000. The kilo is 1000. So from there, the same thing here again I can express. So we can say 1 ATM is equals to everything I'm writing here. Okay, hope that is clear. So what you're going to do is we'll say again I'll extend this point, move it twice bit. I know it moved at first three times to my left. So now again I'll move twice to my left again. So it will move 1, 2. So it will be 1.01325. All right. So now in this case, I'll put 10 to the power 5 pascals. All right. So from there, then we need to know that when I give you um 10 to the power 5 Pascal is equal to actually 1 bar. All right. So this bar is actually just a barometer thing. So we can say, so wherever there's that, I'll put a bar, right? Okay. So I'll say, whenever there's that, I'll put a bar. Okay. So this will be 101325. Then I said this we can impress as bar. All right. Barometer. Something like that. Those who were taking geography can relate this. So that is it. So we can now say that 1 ATM is equal to 10 13.25 Pascal. Again, 101.325 times 10 to the power 3, that will be replaced by what? A kilo. All right. And these are important. You can write them down. Okay. So that's what temperature conversion will be based on. So we need to actually, pressure conversion will be based on. So we need to take a note of this. So hope you are writing them down. All right. So that is it about to um that is it about temperature, something like that. Okay. So hope you have taken note of that. Write them down. These are the points if you missed, especially the first lecture. So, okay. So now suppose you are given to say, suppose that the volume of, let's say, a balloon, okay, increased from 10 liter to what? To 20 liters. All right. At what? At ATM standard room temperature and pressure. So 1 ATM like that. Okay. So I'm just giving you the data. Then we are told to calculate work. By the way, work is equal to negative P. Sometimes you can't put a negative, but you need to know how to manipulate things. All right. So when a work is done on a system, then you expect a what? A positive, because the system has done nothing. But when a system is expanding, let's say a balloon, and it will produce what? A negative. So because the system which is working. So by this, we're saying work is equal to what? Negative pressure times what? Change in volume, like that. Okay. So now we are saying now we have what? The pressure is 1 atm, right? So I'll say, by the way, okay, by the way, let me just take you back and see something here. So you need to know again to say, if I give you, so these are the pressure conversions, and take note that when I say again the same 1 atm, all right, take note of this. This I can show you how to find it, but let's just master it. 1 atm, all right, is equal to um 1 ATM liter. By the way, let me just say 1 ATM liter. Okay, so just take note of this, please. All right, so whenever you see 1 ATM liter, so I'll say liter, 1 liter ATM. All right, this will be equal to 10, all right, 1.3 joules. All right, so whenever there's liter ATM, we'll be putting what? This. Take note of this, please. Okay, so take note of this. So now we can go to the other page. So master this. Okay, so now we are calculating work when actually the volume increased to what? To 20 liters from 10. So we are saying now negative, then P there is what? 1 atm, right? Then change in volume started from 20, that's our final, then minus 10, like that. So this will be what? Negative what? Negative. This is what giving me 10. So that will be we have ATM there, all right. Then this volume is measured in what? In liters. So that will be just 10 liters, all right. So we are calculating work. So what you are going to do is this will be negative 10 liter ATM, all right. So we end there a bit. Now this work is measured in joules. So what you are going to do is we'll use what we call now this this relationship to say Rita ATM, all right, is equal to what? Rita ATM is equals to 10, all right, 1.3 joules. All right. So whenever there's this, we'll put that. So we'll say negative 10 times Rita ATM is actually the value of what? 10.3, like that. 10 joule. All right. So this will give us what? This will give us negative negative 10 1.3 joule. So the point now has been removed. That's the meaning there because of that 10 which is there. Okay. So now we can say this is 3 joules. So when you have a negative in this, the interpretation is that the system was doing work. You see? So it gave what? It's more like you are giving something, you are giving money, or just when a reaction, that one which will be donating electrons, all right, it will actually be positive, right? So now, since the volume was increasing from 10 to 20, meaning that the system what was doing work, and it has given us negative. All right. So that's about to how we can apply that identity and take note of it. All right. So let me give you another scenario. All right. So suppose we are given now, we are told now to convert um 1000 1500, all right, Rita ATM like that to joules. All right. Can we convert to joules this one? So what we do is we bring the identity. Um we said um 1 ATM is actually equal to what? Is equal to 10 1.3 what? Joule. So I'll just replace whenever there's that. All right. Or I can say um I have 8 Rita ATM there. All right. So I have Rita ATM there. All right. Times, okay. So I know to say 1 ATM Rita, all right, is same as what? 10 1.3 joule. All right. So this and this goes, all right. So I'll multiply that. So multiplying that, it will give me actually 15, 19 like that, 50. Okay. If you punch that, then that will be in joules. All right. So that is it about that one. Again, let's say we are told, let's say this is one. So these are the question we had. Then we are told to say convert, all right, convert 300 liter ATM, all right, 300 liter ATM to 1, all right, bar, all right, then 2 meter cubed kilopascal. All right. So hope we have not actually we have taken note of those first pressure conversions. So what you are going to do for the first one, we'll say um we are going to get the same 300, all right, 300 liter ATM like that. We are changing it to bar first. So what you are going to do is we'll take this actually um we'll take first, since we are taking into bar, then later on we'll take into meter kilopascals. All right. Okay. So what we are going to do is we'll say we'll bring the relationships, we'll cancel the meter thing and the liter thing and everything like that. Okay. So what we are going to do is we'll say um can we cancel it like this? Okay. Can we bring a certain relationship? So we are, in fact, I was supposed to say a liter bar, so like this. Okay. So we take into a liter bar and also meter cubed kilopascal. Okay. So now I start. So liter is there, right? We know that 1, all right, ATM, okay. Since we are interested in the bar, 1 ATM, we talked about it. We said is what? One, how many, if you still remember, how many bars? So it was 1 point, all right, 0.1325, all right. Then this was equal to a bar because of the to the power 5, all right. And to the power 5, it can bring the point at this point, all right. So from there, this and this will go. So we'll multiply 300 times this bar, 300 liters times that bar. That will give us what? 303.975 liter bar like that. Okay, so that is it about this one. We have just cancelled and brought the relationship. We talked about this relationship. All right. So now the second one will say we are taking the same 300, all right, liter ATM, okay, then into what? First of all, I'll change these liters. We said 1 liter is equal to what? 0.00 meter cubed. That's what we said, right? So I'll say 1 liter, all right, is equal to 0.00 um 0.001 liter, all right, or I can just say 10 to the power negative 3, all right, 10 to the power negative 3 meter cubed, like that. Okay, so I'm making this meter cubed. That's my first point. So I'll be able to cancel the liter and also the liter. All right, then the second thing that I'll do is I'll come now to ATM, so that I take it into what? Kilopascal. We knew that one ATM, all right, one ATM is equal to what? How many kilopascal are there? You just move the point into 10, 13, all right, 25, like that. So a kilo will come now at this point: 1, 2, 3, all right. So you see, it will be 101.325, like that. Okay, so this gives what? A kilo pascal, all right. So now you just cancel this and cancel this, then you multiply. That will give you what? That will give you 3039, all right, then 7.5, like that, times 10 to the power at negative 3. Then we bring now our expected units, which is in meter pascal. All right. So this is the answer that you are supposed to write. Okay. So now that we have talked about this, so this is the lecture we had, and it won't be nice when we bring everything in one video. Better we do what? Um better we make another video for the next chapter, which talks about derivatives, everything like that. All right, so in the next video we'll talk about derivatives and something like that. So make sure you watch the video, which is so that's what we talked about, in case you missed the lesson. Thank you very much for actually watching the video. See you in the next video. All right.